Hello everybody. In this video we're going to go and see what our exceptions are and how they can actually help us through the code. Even till today we already have some exceptions running in our system. Those exceptions are system-wide exceptions. What is happening when we have a compiler error or source code just break or the compilation just break and it gives us an exception, an error in there. There's way to handle those gracefully and there's way to actually create your own ones too. And they're really beneficial and really helpful in order to have better debugging and a better way in order to make your code or your program to run without having issues. And handle it gracefully when those exceptions happen. What are those exceptions? We can have several ones like a file not found, or a database connection link is down, or the user is offline. I don't know, it could be any kind of situations, right? When we try to send something and that something is not correctly, that will actually send us an exception. And we can actually have different issues in the here and there. So the book have a really good one. Let's start with the simple one, the simple exception. And it have a car class and a radio class and can combine, and when the cars go beyond a specific speed limit, the car just break, right? And then we handle that gracefully with official exception, and then we create some custom ones on top of that, and it's actually really cool. I believe it's a really good example. That's why I want to explore it. So I will go through the process of the book and get that exception, that example working. So as you can see, I'm already in my folder. So let me just create .NET new console, and let's call this simple exception. The same way as the book, actually. Let's wait a minute to this to be created. And then I actually open it in my code or Visual Studio, whatever you want to have it. I will open my simple exception in there. And let's wait another minute to actually to open it. Let me see if I can move this. No, I can't. So my computer is loading and is getting there. Give it a second. Okay, we have that one. It's a simple one. Let's open the main program, CS. Let me do what I like to do in my case, change my space to 2. And reformat the code just a little bit. And somehow it didn't work. Let me check that. Okay, yes, just worked. What happened is it was actually not running. Well, it didn't load everything yet. So we have my application up and running the way it's supposed to. Let's change the main program to using simple exception. And let me delete all this that we don't need for now. Right. And we were going to create something from here. So the first thing I was going to actually be using, I will take in the example for the radio. So we have the example actually what it does. Have a new class called radio.cs, and it's a simple method that pretty much say turn it on or off and use it gaming or quiet time. Yeah, just to give it like an extra indented class in there. And we have a little more complex one that is actually for the car. So let me create that one. Let's call this car.cs and let me save it. Okay. So we have the constant for the maximum speed. We're saying that the maximum speed is a constant of 100. And we have the getter and setter for the current speed. By default is 0. Yeah, the pen name or the name that we actually assign to the car. We have a private boolean that car is dead. It's already broken. We have the music box that is from class radio, pretty much. And then we have a couple of constructors. We have the generic one and the one that we actually specify the name and the speed, right? So we can actually have those assigned correctly. Then we have two different methods. We have the crank tunes, that's pretty much just turn on the or off the radio, and the accelerate. The accelerate will check first if the car is dead. If it's already red, will give you that it's out of order. If not, we're going to increase the current speed by the delta that we assigned. And after we increase it, we check again if the current speed is bigger than the max speed. If that actually happen, we brake the car pretty much, right? We change it. If not, we just say that the current speed is a specific speed, right? It's actually a little more complex, but it's simple enough to understand it. Just reading the code to see what is actually happening here, right? Let me just copy the main one, and I actually let's paste it right here, right? Let me do an extra, enter here, another extra, enter here, and here. So here what the author is actually doing or saying is really simple. We actually don't need a collection or why they actually import it. We will use it later. But for now, this is more than enough. So we're just writing the simple exception example. We assign it the name of, create a new car, name CP, the initial speed is 20. We turn on the radio, right? And then we start accelerating 10 times. And after that, the car is going to brake. And then we have a simple read line in order to make the code not to close right away. So let's execute it. Let's clear my screen. Let's do dotnet run. Oops. I need to go to the folder first. And we execute that. And remember, the first speed was 20. So when we turn on the radio, right, we start increasing this by 10 until we get up to 100. And after 100, CP was overheated and out of order, right? Do an extra enter just to get out. And let's change this to 15 just to see that after it's broke, it just gives you like the car is broken. It's already out of order by default, right? It's pretty much what it's actually doing, and it's simple. So what we are doing here, we have the code working, and we have a message in the console that's actually telling us that this is out of order. But by the system itself, everything runs accordingly. There is no breakpoint. There's nothing saying that, hey, something happened, something bad. Well, somehow, right? But there is no way to limit us or no having those exceptions working the way they're supposed to. Why? The code just execute and behave dependent execution, and it's not notifying us as developers that something is broken, right? It's not saying anything at all. So what we need to do here is what we can actually do through the exception is actually understand those. So in order to understand those exceptions, the way that we can actually use it is with the word throw new. The good thing about C# .NET, specific .NET Core, .NET 5, all the exceptions are actually classes too. So we can actually create a new instance of those exceptions, but we need to throw them in an application. There was a specific way that we can throw an exception before, but now we can actually throw it wherever we want it. So the example what it's telling us is we're going to change this simple write line. That's a normal execution, and we will change this. Actually, we'll move this down a little bit, and we'll change this line to be an actual exception with exactly the same message. The way that we use that is, as I said before, just throwing a new exception, and we're saying the pet name, and this is with a new format where to type that, right? And what's overheated. You see, we actually put 0 here, I believe. We do comma at the end after that. Pet name. This is like the way that it works, but in this case, because we need to format the text in a specific order, that's why we have that little f at the beginning telling us that. Now the exception just accepts one argument, that's why we cannot define it like this, but just to let you know that this is pretty much the equivalent in only one argument instead of two. Actually, I can show you that over here. I believe I can change this to have something like this, to change this to pet name, and removing this, you can see that actually works. So it's just a new way, just have it with only one argument, all the variables that we need, and if we have another variable, we can actually just put the curly braces and put the new variable there, right? That's pretty much how it works. Let me undo everything here and comment that out. We don't need it for now. So throwing that exception will actually help us, and then we'll do something extra. When we do throw a new exception, because we're inside an if statement, the else statement is not needed anymore. Even this one, why it's not needed anymore? Because it's skipped automatically. We can keep it to readability purposes, or we can actually just remove that one from here, and will be this one too. I might comment those out for now. So we will write the current speed until this actually happens, and we'll have to return an exception, and that will actually skip out from to the caller. And who is going to be the caller? In this case, going to be this one right here. So this will pretty much like stop the execution and get out from here. The one who actually called this function to run. So let me save everything and show you how that exception actually shows. So we use dotnet run, and we have a handle exception. Even we are not able to see this several times, because in other things we are saying that it just broke. It's just telling us that 0 was overheated, and it's not supposed to be here, it's supposed to be hit CP. What am I doing wrong here? Oh, yeah. This should be pet name. Right, let me save it. There you go, CP has overheated, we have the same message. It's a system exception, and as a system exception, it's actually breaking the code. As you can see, I don't need to hit enter anymore. To get up, I'm already outside that. And it gives you some kind of trace telling me, okay, this happened in the accelerate method that is in this particular file, in line 43, exactly. We can actually see here line 43 is when we throw the exception. And then we say, who called this? Well, the main program, line 13, call it. So we go back to the main program, line 13. We call it right here. So the exception happened right here. And we know that happened because we have that custom message that was overheated. So now we actually throw an exception. Now we know that something went wrong with the code. And because something went wrong and it's handled as a system exception, the application broke. Now, we need to handle that gracefully. That means that we should be able to catch this, and actually say it's unhandled exception. We need to handle it properly in order to behave or do something about it. And the difference between that and this one is that here we never know exactly that something bad happened through the code. Here we actually know that something bad happened, and we can react accordingly. So what we're going to use in here, we're going to try and catch that exception and be doing something. and it's actually that it will help us to understand what is happening. So let's actually try to handle that, and we will doing that through the program one. So in order to do it, we will wrap this for in. There you go. In a try. Right? It's already grabbed it. And we are going to catch something. By default, when we cache all kind of exception, and we can do something like console.writeline something when wrong. I don't know, something like this, right? So here we have an exception, and that exception will be cached, and this will be thrown. So this will behave a little bit that we have at the beginning. Say that something went wrong, and as you can see, our application is still running. But the rest of those executions that we had before are not doing it. It's actually broke it, and it went outside that execution, but the application is not running anymore. And we are not over-exciting the application either, trying to execute something when something is out of order. We can actually see that something went wrong, and we remove the execution, and we get out from that. So throwing that will actually break that for loop too. A simple enter, because we have a read line, we can proceed. So now we're handling it better. So we're trying, we say try to execute this and cache anything that is in there and show me what is happening, right? The bad thing about this is when we have a general cache like this, we don't know exactly what the error is. We just saw that something happened bad. And this could be something that we can actually have at the end, whenever we have several cache, like, well, cache the rest, and we can call it something really bad, need to be documented, need to be, I don't know, executed differently, whatever, right? We can actually have several catching there, and you can have multiple exceptions to be running. But now let's be a little more specific. Let's actually tell this that we're going to catch an exception. Now let's call this exception E. Right? So exception type E, we're going to catch it, and we know that it's actually what is happening because we had it right here. It's a simple system exception. So let's catch it and let's save it in a variable called E. So we can actually do, you know what? Write that E. What is in there? Let's see let's see what is actually the exception. What's happening? Let's try to execute it and let's see what it does. We have the same exception as before, but we're different that the program is not getting outside. And with that, it should be simple enough, right? But we can actually be, this is actually a class, and because as a class it is, we have several members that we can actually do in order to work better or parse this, let's say parse it a little bit better. So the main ones, we can actually see the target side, we can see the message. So this is actually the message, right? And we can see a little bit the source, who executed. And we can see different sections, different pieces of this error. So we're able to understand it. We can log it in our system or we have it somewhere else. So let's actually copy the one from the book. And I will paste it right here. So I just copy the exception, the catching, and I will paste all this here. So it's the same. I'm catching an exception. I say I'm printing an error, right? But the difference here, as I said before, actually we can actually have, probably we can use this one, it's a little bit better. Something like that. what is happening? It should be working better. Oh, it's not an F, sorry. F is for Python. This is actually a dollar sign. There you go. So we can actually see the method with the target side. We can see the message with the message property. And we can see it's actually a string. Target gets a method throw the current exception. And the source get the set name of the application object that causes the error. If we jump into the exception, we can actually represent an error. And it's a type system exception. Perfect. So with that, we can actually catch it. We can print a little more detailed or parse it somehow and see what it actually does. Let's do Control C. Let's execute this and we can actually see it a little bit better. So the method was the accelerate method. We knew that. The message is the message that we use it, like the pet name over here, right? And the source is the namespace pretty much who caused it. We're able to see a little more information in there. And we can have a little bit better understanding why we actually have that. Now, prior C#7, you can throw as a statement. So you can just throw it only where statements are allowed. After that, you can pretty much put it as an expression wherever you can call it, and you can throw it wherever you need it. That's why it's actually working right now. So we can, those are not the only methods that we can actually use. And let me show you other ones that we can actually execute. Let me get up from here. Let me get back to the code and let me paste all this information. So with target type, we can actually have the declaring type that get a class that declares this specific member. And we have the member type too that will override, it will give us exactly type of the member, method, construction, event, and so on that actually execute the error, right? So target type give us those two sub elements, sub properties that we can actually see a little bit better. Let's execute. And we can see, yes, it happened to accelerate, but that happened in simplest in the car class. Yes, and this is actually a method. It's telling me that it's a method, right? Now we have more understanding about the error and what is happening and what it is. So imagine that you have a really big source code here, and going through here, you actually need to start opening the files to try to understand what it is, what is happening there. But if you have understanding of your code, you can say, oh yes, it happened in a method, in the car class. So it gives a different kind of context that you can troubleshoot your application itself. That's pretty neat. Now, those are not the only ones, as I said before. We have the stack trace too. And the stack trace, what it does is actually all this from here. This is pretty much like the stack trace, like the default error. Let's actually try to put the stack trace 2 at the end. And let's execute. And we can say the stack trace is pretty much the last part without the message. Right? This section that we're seeing before is the stack trace. And this is the one that actually gave us right here what is the issue. So we have, again, a little more context about the issue. Now, the target side and stack trace properties allow programmers to gain understanding of a given exception. This is a little use, this doesn't have use for the end user, right? So if we have like a tutorial or we have like a help page or something like that, we can actually find it in a help link. So if we manage the help link here, we can actually send the user to a specific place. So the user will say, oh, something happened, let me go through that, right? The best example is whenever we have an issue with the Windows computer, they actually say, oh, you know what, you can actually see the issue over here, you can see the issue over there, and you can read about this error. And that will help us understand a little bit better. So we can actually handle that that help link is not given by default, so we actually need to specify the value. So by default it's an empty. But in order to do it, we need to find it whenever we create the instance of the exception itself. So let me go back to my car. So we throw in a new exception. We create an exception right here. And we know that we can actually put, just before the semicolon, open, close, curly bracket, and have a property with a specific value, right? So we're giving the help link, and we're using that car or us is, or whatever, for example, let's call this for example. It's like, you know what, you can go to this page to read about this issue, right? If a known issue, you can gracefully handle it in your application in order for your user to see it. And having that exception, we can actually just print it through the help link in our application. So we can actually go here, and we can actually go and see, you know what, now show me the help link, and we should be able to see that link that we created before. I just get out, I just will execute, and just help link, we tell it, you know what, go to example.com, you are ready to go, right? Now, context is everything. And context is the one that will help understanding things. Whenever we have, and I put a Windows computer as an example, we have an issue, it actually tells us like error code and it's giving us a little more information, at what time it happened, things like that, right? Right now, we can show those, or we can actually save those wherever we need it. So we as developer, we can go back and say, you know what, this error happened exactly at this particular time because we are saving that. Or something happening, like why it happened, we can actually handle that a little bit better. And we can have like custom data on top of the exception. So those data elements are actually dictionary collections. And we're going to go to collections in a later video. Yeah, we'll talk about genetics and not. But for now, let's say it's like it's a key value store. If you came from JavaScript world, say like I would say like a JSON file, we have a key and a value. It's something like that, and it can be iterate, and you can move from the beginning to the end. So you can actually retrieve those, and you can actually have those elements, and those go to the data property. So the data property by itself, as I said before, is a dictionary that you can loop through, and you can add several elements in there. So let me just go back to my implementation. And after my help link, I will create, you know what, now I have something with my data. Right, and I have an issue here. Oops, I need to close my data. Like that. Yeah, it looks like that. And let me just put this one a little bit ahead. And what I'm saying, I just put in a couple timestamp. I created a timestamp key with the value the card exploded at this particular time. We're saying exploded at this particular time that I'm executing or I'm recording this video. And I have a cows, I have a list put, and I can actually recall what else? I don't know. You can put whatever you need. You fail, right? Yeah, and you can have that key element. The way to put it is inside curly brackets, inside the main curly brackets of the data, separated by a comma, and it's a two keys, the keys and value, separated by a comma itself, right? And you can put all that you actually want to have it there. In order to see those, it's going to be a little bit different to make it work, because now those ones are actually dictionary. We need to loop through those dictionary entry in order to understand that, right? So all those is going to be actually saved in our data element. So let me just try it to do a simple like this. Actually, what the book doing is actually create like a new line, and I could add like an arrow in there and just put it like custom data. That's the data that we created, And for now, just put the e-data and to show how it actually looks like, right? Without looping correctly inside that. So let's see what it actually does. Custom data, we can think that it's a simple collection. So we need to iterate through that list dictionary internal in order to see that information, right? And we'll go through collections, as I said before, a little more deep in a later video. Or for now, imagine like an object with different keys. Look at, it's a simple dictionary, right? So in order to make this work, we just print the custom data like this, and we do a simple for each after that. So we have a dictionary entry called the DE, and that dictionary entry for that is e-data, because we know that everyone is a dictionary entry. We just print the dictionary entry key and then the value. Right, and we have all of those printed right there, separated by semicolon. Now, in order to make this work, you say that could be loaded using dictionary word assembly. We need to actually import the other one that we had before, that I believe is using system collections, I believe. There we go. Yes, using system collection, and we can actually get the dictionary entry that actually came from there. If you have Visual Studio, probably that just came up automatically for you. So after we have this and we loop for each every entry, we will be able to see all the custom information, all the custom data that we specify. We specify a timestamp, it's given the time and hour. We specify the cows, right? And what else? It just fails, right? The one that we just created. This one came from the book. We just create this one extra, just for fun, to see that it's that simple to create a new one. So you as developer, you can put any quantity of data, or you can actually save like the state of your application, like these were the properties that trying to execute this and it fails, so you will understand where it's actually happening, and you have a little more big picture and how to handle the exception and how to solve it in the future. As I said before, this will help us to have a better troubleshooting in our application, right? And pretty neat. This is actually a system level application. Now, as I said before, you can actually create your own exception, and you can actually derive from the exception system level. Well, there is another one called application level, application exception. The application exception by itself is actually already came in from the exception system level. The book actually gave us 3 different ways to actually do that, and you will see take 1, take 2, take 3. Each one of those is a little more complicated, but at the end actually gave us having our own exception with our own name. So we can actually say, you know what, something happened and we call car death exception. We know that car death exception happened when the car just broke. Things like that, right? The process is really straightforward. I just recommend you to go through the book, and you will see that you have how to execute those. And then after that, you will see a way how to chain those exceptions. You can have one after another, and you can actually just catch different ones. And you can say, okay, something happened, or this happened, or this happened, or at the end you can do a generic catch. You will make sure that your code is running smoothly, and you're behaving differently depending what is happening, or you are reporting what you need to happen. In a real more world scenario, you can actually, when an exception happens like this, that is an error, we can gracefully give a message to the user, but you can actually send like an email to the developer group and say, you know what, something broke because of this, and you can have all the data be sent to there. So that's pretty much what we have it, right? It could be like an alert system for you as a developer or for your team. So other than that, I don't think we need to go more deep than this, and the book is really straightforward. And try to go through the example. As you can see, right now, this is the main example. And just go through the other 2, and you should be ready to go. Meanwhile, I will say, any question, any doubt, don't hesitate to reach me. Happy coding, everybody.